Hello everybody, today is April 7th, 2020. And today we will be talking about section 2.8, which is combining functions. Combining functions and composite functions. Okay, so just like we can add, subtract, and multiply and divide numbers, you can do the same with functions. So here are just some definitions. For example, so these are all talking about combining functions. So later we'll talk about composite functions. Okay, so f and g are two functions. Then people sometimes write f plus g of x equals f of x plus g of x. You can also do the following. F minus g is just f of x minus g of x. F times g of x is f of x times g of x. And sometimes people write this as, with parentheses here, and then finally division, f over g of x is equal to f of x over g of x if g of x is not equal to 0. It can also be written as f over g x. Okay. Alright, so it's pretty straightforward. So you're basically, this new function f plus g and these new functions, these are one function, but it's pretty straightforward that if you're adding, you just add the two functions, subtracting, you subtract them. Multiplication is multiplication, and then division is division. Okay, so let's do some examples. So f of x is equal to x squared minus 6x plus 8, and g of x is x minus 2. Okay, so first we're going to find f minus g of 4. Okay, so first we can take f of 4 plus, so this is equal to f of 4 plus g of 4. Oh, minus. So this f of 4 is 4 squared minus 6 times 4 plus 8. Okay, and then I'm going to do a minus, and I'm going to make it in parentheses g of x, so I don't forget to distribute the minus. 4 minus 2. Okay, so this is equal to 16 minus 24 plus 8. Okay, and then we have minus, we can do minus 4 plus 2 or just minus 2. Okay, so 16 minus 24 is negative 8, plus 8 is 0, minus 2 is minus 2. So that's how you do the first part, for part A. Okay, so let's do part B. So we have, they want us to find f divided by g of 3. Okay, so this is going to be 3 squared minus 6 times 3 plus 8 divided by 3 minus 2. And notice you can do that because when you plug in 3 here, g of x is not equal to 0. But if you would have done f divided by g of 2, you run into a problem because then you're dividing by 0. But that's not the case. Okay, so this is 9 minus 18 plus 8 divided by 1. So 9 minus 18 is negative 9 plus 8 is negative 1. So it's negative 1 over 1 or just negative 1. Okay, so let's do another one here. So we have C is f plus g of x. So here we're actually making a new function. We're defining it in terms of a variable. Okay, so in these two we just evaluated the function, this function f minus g and f divided by g at points, but now we're actually defining it as a function here. So we have x squared minus 6x plus 8 plus x minus 2. Okay, so now we're going to combine our like terms. So we have x squared minus 6x plus x is minus 5x. And then we have a plus 8 and a minus 2, so that's going to be plus 6. Okay, so this is our answer. Okay, so let's do another one. So this one is now f minus g of x. Okay, so we're going to do x squared minus 6x plus 8, and here's where it's useful to use the parentheses. Okay, so this is distributing out this negative. We get x squared minus 6x plus 8 minus x plus 2. So this one is going to be x squared. Now, minus 6x minus x is negative 7x. And we have a plus 8 and a plus 2, so this is now plus 10. Okay. Alright, now let's do a multiplication. So we have e. So we've got f times g of x. So this is f, so it's x squared minus 6x plus 8 times x minus 2. So we've got to do some foiling here, right? So we've got, so we get a x cubed from the first term and a minus 2x squared minus 6x squared plus 12x plus 8x, and then finally minus 16. Okay, So now I can combine like terms. So this is going to be x cubed. There's only one x cubed term. But now we have a minus 2x squared minus 6x squared. So that's going to be a minus 8x squared. Then we have a 12x plus 8x, so that's plus 20x. And then minus 16. Okay, so that's the simplified version. Okay, and last but not least, f. Okay, so in this division, f divided by g. So it's going to be, remember the definition is f of x over g of x and g of x not equal to 0. Okay, so it's x squared minus 6x plus 8 divided by x minus 2 when x minus 2 is not equal to 0. Okay, so this is going to just be, we can factor f if we want to simplify this. So we need two numbers that multiply to positive 8 but add up to negative 6. So x minus 4 and x minus 2 do the trick. And then we have x minus 2 over here. When x is not equal to positive 2, right? I just added both 2 to both sides here. Okay, so now we can cancel this. So this is equal to just x minus 4, but we still note that that's only when x is not equal to 2 because of the original definition of the function. Okay? Right. So this leads us into this. Okay, so I want to make a key difference here. The function x minus 4 when x is not equal to 2 is kind of like it's different from just the function x minus 4 because you can plug 2 into that. So you have to make a difference, right? X minus 4 when x is not equal to 2 is kind of like a piecewise function. It's kind of like x minus 4 when if x not equal to 2 and undefined if x equals 2, right? This piecewise function here is the same as this function here. But this piecewise function is not quite the same as x, just plain old x minus 4 without this specification, right? It's because it has two different domains, right? If you just had x minus 4 without the specification, the domain would be negative infinity to infinity. But here, this function, x minus 4 with this specification, or defined this way, has a different domain. Its domain is negative infinity to 2, or 2 to infinity. Okay, so that leads us to our next discussion here, is finding the domains of combinations of functions. Okay, so let's let f of x equal the square root of x plus 2, and we're going to do g of x is the square root of 5 minus x. So the instructions are find the domain of f plus g, f minus g, and f times g, and f over g. Okay, so let's do the first one. So f plus g, first we should probably figure out what f plus g of x is. Well, it's the square root of x plus 2 plus the square root of 5 minus x. So we have two square roots here, so remember that we cannot put negative, we cannot put negative numbers into the square roots, right? So since we have two of them, we actually have two different domains that we need to consider. So for example, we need x plus 2 has to be greater than or equal to 0, and 5 minus x has to be greater than or equal to 0. Right, because I need positive numbers in both of these square roots. So we've worked with inequalities before, so just unless you're dividing or multiplying by a negative number, the inequality stays the same, right? So in this one I subtracted 2 from both sides, and on this one I added x to both sides. So this tells me that x has to be greater than or equal to negative 2, and 5 is greater than or equal to x, or x is less than or equal to 5. So if we draw our number line, it's going to be 0, 1, 2, 3, 4, 5, 6, and negative 1, negative 2, negative 3. So since we have these less than or equal to, we use square brackets, and there's our domain. So our domain written in interval form would just be negative 2 to 5. Okay, and it turns out that if I were to replace this, f minus g of x is the root of x plus 2 minus the root of 5 minus x. So in this case, I still need both of these numbers to be greater than or equal to 0 inside these square roots, right? So I'm going to end up getting the same exact interval by the same process. If they're not above 0, they're not defined, and I can't subtract them, or I can't add them. Yeah, and similarly, if I do f times g of x, it's the square root of x plus 2 times the square root of 5 minus x. So you could write that as the square root of x plus 2 times 5 minus x. Okay. So here we could use that point test point method to figure out the domain of this. But think about it. If I want to multiply, I need this, still need x plus 2 to be positive, I need 5 minus x to be positive, and it turns out if we can't have them both being negative, because then, wait a second here. Right, sorry about that. So so if we use our test point method, right? That's the one where we draw our interval here, just to refresh. 0, 1, 2, 3, 4, 5, and then 6, negative 1, negative 2, negative 3, and so on. So our first, we break up our, right, the test point method, remember we would solve the inside function here for the zeros, right? So if I plug in x equals 5, I get a 0, and if I plug in x equals -2, I get a 0. So our one interval is -infinity that we need to test is -infinity to -2, and then we have -2 to 0. I'm sorry, not to 0, but to 5. And then we have 5 to infinity. Right, so we pick our test points, right? They could be any number in the interval. I'm just picking some of them. So if I put a -3 in here, -3 plus 2 is a negative number. 5 minus -3 is a positive number, right? 5 plus 3. So we have 8 times -1. That's a negative number in here, so it's undefined. Okay, when I go to 0, though, I get 0 plus 2, and 5 minus 0, positive times positive is positive, and you can take the square root of a positive, so that checks out. And now if I put a 6 in here, it's 8 times -1, and you have the square root of negative number again. So the domain so we see that the domain is actually -2 to 5, and if we plug in -2 and -5 to check the endpoints, if I plug in -2, it's a 0, and you can take the square root of 0, and if I plug in 5, it's 0 again, and you can take the square root of 0. So the domain for, we see that the domain for f plus g, f minus g, and f times g is -2 to 5. Okay, and that's a common theme. So it's the domain. So if we look at just the domain of f, and then we look at the domain of g, then the domain of f, remember if we did it up here, is x is greater than or equal to 2. So the domain of f is, square bracket -2 to infinity. That's what x greater than or equal to -2 means. And then the domain of g was 5 greater than or equal to x, or x less than or equal to 5. So that one's going to be -infinity to 5 included. So it's, for these, it's just the, for the domain of these three, it's always just the domain of g and, right? Because if you wanted both of them, it would be precisely this. Right, because you can think about it on our number line. If here's 5, and here's -2, and here's 0, then we want everything, one domain, the domain of f is everything greater than -2, and the domain of g is everything less than 5. And we want the overlap. That's what and means. Okay. Now, there's one additional thing that we got to look out for when we're talking about division. So it is, again, it's going to be it's D1 and, remember this upside down U is and, the domain of 2. So D1 is the domain of f. And D2 is the domain of G. Right. Okay, so you need to do one more thing. So you need to test endpoints. Since, or look for, it's, sorry, you need to look for points where g equals 0, right? Because you cannot divide by 0. So we now set g equal to 0, or square root of 5 minus x equal to 0. So if the square root of a number is equal to 0, then that number squared is still equal to 0. So 5 minus x equal to 0. So 5 equals x is when g is equal to 0. So because of the whole thing, remember this is when g is not equal to 0. Our domain for f divided by g is a little different. It's actually, we're gonna actually keep -2 because that's okay, and we're gonna keep everything up to 5. But now instead of a square bracket here, we're gonna have a curly or a regular parenthesis, right? And then if we actually look at what f divided by g is, it's the square root of x plus 2 divided by the square root of 5 minus x, right? So that makes sense because if I plug in a -2 here, I just get -2 plus 2, which is 0, divided by the square root of 7, which is just 0. But if I plug in a 5 here, I get 5 plus 2, which is 7, divided by 0. That doesn't make any sense. Okay? So the key is when you're looking for the domain of f divided by g, you have to consider when g is equal to 0. And then once you find those numbers, you have to exclude them from the intersection of the domain of f and the domain of g. Okay, so we've talked about how to combine functions and then also finding the domain of their functions. And once you know how to find those, once you can find a combination of two functions, finding the domain is just like finding the domain of a function. You just find the domain of the function that you combined, or the two functions that you combined. And then finding the range is the same way as we found the range of any function before. So now we're going to talk about something a little different. So this is the composition of functions. Okay. Or composite functions. Okay. So these are written as if again f and g are two functions. Then we can write the definition of a composite function is f and then this little o, f of, and we say this means f of g of x. Okay, and the way we write it is f of g of x. So it's like if I just had f, right, it would be f of x, but now I'm going to take, if I have f of g, I'm going to take the g of x function and input it to the f function. Okay, so for example, if I had g of x, let's say g of x is equal to x squared minus 1, and f of x is equal to the square root of x. So if I want f of g of x, then it's f of g of x. So I'm going to write this in a couple steps here. So this could be f of x squared minus 1. So basically what I do is, I just inserted g of x into, that was a straight up substitution. But now, now I need to take x squared minus 1 and put it into to where x is for the f function. So this is going to equal the square root of x squared minus 1. Okay, but you can, so we also have to notice that, g of f is not always, it's not the same in general, right? This is now g of f of x. So this one is different. So now this is g of the square root of x. So now wherever I see an x in the g function, I have to put the square root of x, right? When I did f of g, it was wherever I saw x in the f function, I put x squared minus 1. So this is now going to be equal to the square root of x squared minus 1, or x minus 1, right? So these are two very completely different functions. So the order does matter here. Okay, so now let's do an example. So this example, we let f of x, sorry, I'm writing really messy today. F of x equal to x cubed, and g of x is equal to x plus 1. All right. So we need to find, they want us to find a f of g of 1. So this is the same thing as f of g of 1 by definition, right? So now I need to figure out, whoopsies. So when we're just talking about a variable, like the example I just did was right, this example we had to just use the variable x. We did f of g of x, but now we're actually evaluating, so you can do this a little bit easier. So this is f of, right, 1 plus 1. So this is equal to f of 2, which is equal to 2 cubed. Okay, so then for b, they want us to do g of f of 1. So this is g of f of 1. So this is g of 1 cubed. That's the f function here. So this is going to be 1, right? So this is, sorry, let's do another step here. So this is g of 1, right? 1 cubed is 1. So then this is g, and g is x plus 1, so it's 1 plus 1, or 2. And, sorry, 2 cubed is 8. All right. Finally, okay, so this one is a little different. They want us to do, for part C, they want us to do f composed with itself of -1. Okay, so this one is going to be f of -1. And then f of -1, so f of -1 cubed is equal to f of -1 times -1 times -1 is -1. So, and then this is equal to negative 1 cubed. So this is equal to negative 1. All right, let's do a couple more practice problems here. So this one's, so now let's change it up. So new example, so we have f of x equal to negative 5x and g of x equal to x squared plus 1. So they want you to find f of g of 0 and g of f of 0. Fog and Goff, or this is kind of a joke, or yeah, whatever. Okay, anyway, so we have this one, we are going to do f of g of 0, f of, so g of 0 is 0 squared plus 1, so this is f of 1, which is equal to negative 5 times 1, which is equal to negative 5. Okay, this one is g of f of 0, which is equal to g of negative 5 times 0. Right, and this is where we can get confused because, so remember here, this is function notation. This is not multiplication. This is saying I want to evaluate f at 0. This one is different because this is not saying I want to evaluate negative 5 at 0. This is saying I want to multiply negative 5 times 0 with these parentheses. But then this outer parenthesis is not saying I want to take g times whatever's in the parentheses. It's saying I want to evaluate the function g at whatever's inside its parentheses. Okay? So this is now g of 0, and that's equal to 0 squared plus 1, or 1. Okay, so that's how you evaluate composite functions. So now let's find some composite functions. So this is going to be kind of what we did in what I just did in that the example before these two. So in this one, f of x is going to be 2x plus 1, and g of x is x squared minus 3. So they want A, f of g of x, B, g of f of x, and C, f of x. Okay, so now go ahead and get started. So we have A, we take f of g of x, so that's equal to f of x squared minus 3. Okay, I'm just substituting x squared minus 3 in for g of x here. And now, instead of input, right, if f of x is equal to 2x plus 1, then f of x squared minus 3, wherever I see an x here, I have to put x squared minus 3 instead. So this is going to be 2 times x squared minus 3, right, 2 times x, or 2 times your input, right? Here we're just inputting x, and here we're inputting x squared minus 3. And then I can't forget about the plus 1 there. Okay, so this becomes 2x squared minus 6 plus 1, which is equal to 2x squared minus 5. Okay, good. So that's part A. So if we move on to part B, so we have g of f. So we want to do g of f of x, which is equal to g of 2x plus 1. So here, the input here is x, and I get x squared minus 3. So now if I'm inputting 2x minus 1, you should get 2x minus, I'm sorry, so I said input 2x minus 1, I meant 2x plus 1. So I put a 2x plus 1, the input where the input goes here. So it's 2x plus 1 squared, and then minus 3. Okay, so if I FOIL that out, right, that's 2x plus 1 times 2x plus 1 minus 3. Or if I rewrite that squared as just the definition of what squared means, then this is going to be 4x squared plus 2x plus 2x, and then plus 1, and then minus 3. So this is equal to 4x squared plus 4x minus 2. Okay, so now to do f of f, we need f of x. So this is f of 2x plus 1. Okay, so now this is a little confusing, but wherever I see a x here, I'm inputting x and I get 2x plus 1. So if I input 2x plus 1, I should get 2 times 2x plus 1 plus 1. I put a 2x plus 1 wherever I see an x here. So this is equal to 4x plus 2 plus 1. So that's 4x plus 3. Okay. All right, so we've had some practice with that. So now we're going to talk about the domains of composite functions. Okay, so let's say we had f of x equal to 2 over x minus 3, and g of x equal to 5 over x plus 1. And they want you to find the domain of f of g. So it's actually, we have to first look at, right, so this is f of g of x. So we'll look at this in two different ways here. So first you have to look at the domain of g. So we've got to look at the domain of g. Remember, we have to look for square roots or divisions, right? So we have a division here, and we cannot be dividing by 0, so we need to figure out when the denominator is 0. So we set x plus 1 equal to 0. So that's saying that x is equal to -1. So that says the domain of G is everything, so it's -infinity to -1 or -1 to infinity. Okay, so now let's take a look at the domain of f of g of x. So this is 2 over g of x minus 3. So I didn't substitute g of x in here for a reason, just because I didn't want to write a messy fraction divided by a fraction. So the domain of f of g is it's undefined. We have a division here, so we need to watch out for that division. So if g of x is equal to -3, then we have a problem. So we're going to set g of x equal to -3, or 5 over x plus 1 equal to -3, because we want to see when this g of x is equal to sorry. G of x minus 3 equal to 0. Right, we want to see when this denominator is 0. So it's actually g of x equal +3, or 5 over x plus 1 equal to +3. So to solve this for x, we can multiply both sides by x plus 1. So we get 5 equals 3 times x plus 1. So this is 5 equals 3x plus 3. So if I subtract 3 from both sides, you get 2 equals 3x. And then this says that x is equal to 2/3. So this one says that x, right, because this is in fact, if x is 2/3, g of x is equal to 3, and f of g has a division by 0. So in fact, this one says our domain here is -infinity to 2/3, or 2/3 to infinity. So in fact, it turns out that we need both of these things to be true. We can't have x cannot be equal to -1, and x cannot be equal to 2/3. Right? Another way of writing this is, this one up here is x is not equal to -1, and this one is x is not equal to 2/3. So you need all of them to be true, or both of them to be true. So in fact, the domain is going to be -infinity to -1, or -1 to 2/3, or 2/3 to infinity. You just cannot have, this is the same thing as x equal to -1 or 2/3. So that's how you find the domain of a combination of function, or composite function, sorry. Okay, let's do one with a, so we did one where f and g were both fractions or rational expressions. So let's do one where f of x has a radical involved. So x plus 1, and g of x is equal to 2 over x minus 3. Oh, okay, so it's f from the old problem. But anyway, they want you to find the domain of f of g. So another way you can do it is just like I was saying before. You can just you can literally just find what f of g is. So if I do f of g of x, you can do so remember that's f of 2 over x minus 3, which is equal to the square root of 2 over x minus 3 plus 1. Okay, so in this one we've got to be careful because we have a square root and we have a division here. So I need to first figure out well, if I put x equal 3 in here, then it's 2 divided by 0, and that's no good. Right? So x cannot be equal to 3. And then the reasoning is division by 0. Okay, so now the other thing we have to take care of is the square root. So I need 2 over x minus 3 plus 1 has to be positive. Or sorry, not positive, but it actually has to be non-negative. There's a difference, right? Non-negative includes 0. Positive does not include 0. Okay? So if I want to solve this for x, I would probably subtract 1 from both sides. So I get 2 over x minus 3 is greater than or equal to negative 1. Oh, wait. No, that's not how I want to do this. Sorry. So I'm going to first find the common denominator. One second. Okay, so I first find the common denominator. So I need 2 over x minus 3 plus x minus 3 over x minus 3 is greater than or equal to 0. So this is now 2 plus x minus 3 over x minus 3 greater than 0. Greater than or equal to 0. So, so remember, now we can use the test point method. So this is, well, let's simplify this. So 2 minus 3 is x minus 1 over x minus 3 is greater than or equal to 0. Okay, so we've got to look at our, when the numerator equals 0, so x minus 1 equals 0, and x minus 3 equals 0, right? Numerator and denominator equals 0. Well, this one we already solved for. This is x equal 3, and this one x is equal to 1. So if we draw our interval here, we have 0, 1, 2, and 3. So our intervals that we need to test are 3 to infinity, 1 to 3, and negative infinity to 1. So in this one, I'm going to choose 0 as my test point, 2, and 4. Okay, so if I put a 4 in, I get a positive over a positive, so this one works. If I put 2 in, I get 2 minus 1 over divided by a 2 minus 3, so a positive over a negative, so that's saying that a negative number is greater than 0. So this one does not work, so we'll put a little x right there. And then if I do 0, it's 0 minus 1 negative, 0 minus 3 negative, so a negative divided by a negative is positive, so this interval works. Okay, so and we already said our intervals are negative infinity to, so first we have to test our endpoints too, right? Because if I put in 1, I get a 0. So it's 0 divided by 1 minus 3. Well, it's 0 divided by negative 2. 0 is greater than or equal to 0, so we're going to include 1. Or skip this interval. 1 to 3 does not work. Or, and then now we have to test 3, but actually we already did that up here, right? Because we already know that if we put a 3 in there, we're going to get a division by 0. Okay, so we actually have a regular parenthesis there, and then we're going to go to infinity. Okay, so that's how you do one with a square root in it. So sometimes you can look at the two domains of f and g separately, or you can just find the composition function and then find the domain like we would have in a couple of sections ago. Okay. All right, so let's do one more of those practice ones. Very good practice. So now let's go ahead and let f of x equal 1 over x, and g of x equals 3x minus 12. So find the domain of f of g. Okay, so this one's going to be, so let's do it the method where we just find out what f of g is first. So f of g of x is just going to be f of 3x minus 12. So that's 1 over 3x minus 12. Okay, so the only thing we have to worry about here is the division by 0, right? There's no square roots, so we just have to see when the denominator is equal to 0. So we set 3x minus 12 equal to 0. So notice I can factor out a 3 on both of these terms, so I get 3 times x minus 4 is equal to 0. Dividing both sides by 3 is x minus 4 equals 0. 0 divided by 3 is still 0. And then this says that x is equal to 4. So if x is equal to 4, the denominator is equal to 0, and we get a division by 0. So the domain is x not equal to 4, or you can write it in an interval notation as negative infinity to 4, or 4 to infinity. Okay, so now we're going to do one with two square roots. So if I let f of x equal the square root of x minus 2 and g of x equal the square root of 4 minus x, then they want you to find the following functions and their domains. Okay, so for the first one, they want you to do it for f of g. Okay, so f of g. Let's first find the domain, or we can first find the function. So f of g of x is equal to f of g of x, which is equal to f of the square root of 4 minus x. So this is equal to the square root of 4 minus x minus 2. Okay, so if we're going to find the domain of this, then, so that's the function, right? That it's a little messy, but that's what it is. So, right, so then, so this is f of g. So if I want to find the domain, I need what's inside of this square root to be positive, and I also need what's inside of this square root to be positive. So I need 4 minus x to be greater than or equal to 0, and I need the square root of 4 minus x minus 2 to be greater than or equal to 0. Okay, so one sec. So, okay, so I need both of these to be equal to 0. So for this first one, we need, we can solve this if I add x to both sides. This is saying that 4 is greater than or equal to x. Okay, so this one now, to solve this one, I'm going to add